according to the cloud server. Good morning, all of you. Logging in, yes, that's the beautiful doorbell. Today is December 4th. You know what today is? It is National Cookie Day. Yes, we have all kind of bizarre holidays that people pay attention to. National Cookie Day, I believe, should be one that should be much more important. We have Labor Day, we have 4th. Why don't more people understand today is National Cookie Day? So, what do I suggest you do? Go out and eat a cookie. Pretty straight. All right, what we're going to do today is not talk more about National Cookie Day, but instead what we're going to do is we're going to basically talk about the last big topic in this class. And the last big topic is what happens. Left-hand side variable is a binary, 0. So let's go to the Questrom Tools website. Last time we were talking about experiments. And the idea is, does an experiment work? Yes or no? That is your left-hand side variable. The experiment worked. The vaccine protected us. The vaccine did not protect us. And what we're going to do is we're actually going to run regressions, and we're going to see the impact of various factors on that yes-no decision. So I'm going to come to B1. I'm going to click on resources. And under resources, the file we're going to do is, there it is, lecture 25, probability models. So I'm going to open that up. And since we're here on the class website, the data file we need is WSJ2. So under data files, it's Wall Street Journal 2.
Professor, your screen is not sharing.
Oh, my screen is not shared. Thank you. Thank you very much. Let me just go back to where I was. What file do we need? We need lecture 25 probability models. That's the one we're doing right now. And the data file we need is WSJ2, which is down the very bottom of the list. There it is. WSJ2, it's below the coin flipping one and above the electricity experiment one. So we'll open both of them up. Let me stop sharing that, and Gunsha, tell me if I'm sharing the PowerPoint in 1 moment.
Yeah, sure.
It should not be up yet. Share screen. So Gunsha, you should now be seeing predicting probabilities.
Yeah, I can see that.
Great. All right. So we're all hopefully on the same page. And so far, what we've been doing is all of our regressions on the left-hand side have had variables with lots of different cases. For example, the Brookline condo data had all these different numbers. There was, I think, only like 3 condos that were the same price. But out of 1,000 condos, almost all of them were different kinds of numbers. When we've done some other cases, such as the ticket sales for Hollywood movies. On the left-hand side, we had ticket sales. There wasn't a single number that was the same on the left-hand side. They were all over the place. Some movies did well, some movies did poorly. What we want to do is we now want to switch. Pointing to the screen doesn't work, I guess. What we want to do now is switch and have a limited number of cases on the left-hand side. So for example, instead of the number of books being sold, which could be based on education or income, does someone buy a book or not? So you're Amazon or you're some other website like Amazon and you're selling things and somebody comes to your website. Are they going to buy? Are they not going to buy? What can you do about this? If you have a good model that predicts accurately who will buy, who won't buy, then you can customize the price. If you know that this person is sort of on the fence, show them a low price. If you know this person is like, oh, they're definitely going to buy, it's like, I know their characteristics because I have cookies and I've been following their web history for a while, I can offer them a high price. You can do something called price discrimination. In general, discrimination is not a good word in the United States or around the world, but price discrimination is a little bit different. What we're doing is we're charging people slightly different prices because some people really want the product or the service and other people don't. Home price, we did the Brookline regression. We looked at location, number of bedrooms, bathrooms, size, all these kind of things, but does a home sell in the last month? This is important. Some of you will grow up to become realtors, and somebody will walk into your office and you will size them up very quickly. Are they a serious home buyer? Should I spend a lot of time and effort on this person? Or are they just sort of what we call in the Brookline area called a tire kicker? They walk in, they want to look at a few places, but they're not really serious. If something really grabs their attention, then they'll maybe buy a house, but maybe not. So do you spend time and effort on these people, or do you not spend time and effort on these people? So how do you answer these questions? Linear probability regressions. So linear probability regressions are really useful because they give us the ability to predict things. How many restaurants are going to survive, or which restaurants are going to survive the pandemic? Let me ask you just a general question. Feel free to unmute yourself or raise your hand or something like that. What do you think are the characteristics of restaurants that will live through COVID-19? Restaurants can't get sick, humans do. But restaurants die and they're born just like people. So Kira, what do you think will cause a restaurant to make it through the COVID-19 pandemic?
They have to be adaptable, be ready to like send food out and do delivery in some way.
Right. So restaurants that are able to do takeout probably have a higher probability of surviving. Restaurants that have no ability to do takeout probably are not going to make it through. Isabella is the only one here, Rithvik, if you're taking attendance, so it's just the two of us. Almost a private lesson. Okay, so Isabella has her hand up. Go ahead.
So basically, if they have like their previous debt, and if like they have an accumulation of debt.
So Isabella, for those who can't hear her, is saying amount of debt. Restaurants that have relatively low debt levels will probably survive. Restaurants that have outstanding loans probably going down the tube in the next few months. Kevin, sorry.
I was gonna say having like a loyal customer base, so making sure that like your customers aren't gonna go to another place if you decide to like close down, or like if your services aren't like up to par as they usually are potentially.
All right, so loyal customers, they might be willing to cut you some slack if things aren't exactly the way it used to be. Great. Ashley.
Restaurants that don't rely on alcohol sales.
Does that help or hurt?
Like if they don't rely on alcohol sales, like regular takeout, like Chinese restaurants or something, they'll survive. But if like, for example, like bars that rely on like the experience, and like alcohol sales and like socially the environment, they'll fail, I think.
All right, so restaurants that really are selling primarily food will survive. Restaurants selling experiences like alcohol are probably not going to survive. Great. Filippo and then Isabel.
Outdoor seating and like whether or not they live in a place where they can sit a lot of people outside, or if they're like in a city where they have no space.
So Filippo is saying that restaurants, at least here in the United States, in the South will probably survive at higher rates than those in the North. And those who are more rural areas or suburban areas will probably have a higher survival probability than those in dense urban areas. Okay? Isabel and then Ayush.
I think like how long they've been open. So if a restaurant just opened right before COVID hit, they probably won't do very well.
Okay, so time of existence, great idea. Ayush, and then Alana.
So I was going to say two things. One is kind of the management, like did they do well during other times of uncertainty, like maybe 2008? And then the second one would be, do they already have like a strong online presence in terms of delivery? So like a place like McDonald's would obviously survive because they have this big online presence as opposed to like a local shop, which might not be on Grubhub per se.
Okay, big online presence. Let me say I had to teach a group of MBAs last night. I walked home via Comm Ave. Usually I walk home via Beacon Street. And there was only one place that was doing booming business on Comm Ave, and that was Taco Bell. Like there was like a line outside the door. The BU students all standing, yes, with masks on, all 6 feet apart. If anyone outside of BU is listening, but I was like, what? What's going on here? Taco Bell. All right, so big online presence with a long history, especially among college students. Great idea, Ayush. Ilana, and then Nirana.
Maybe if they're located in a higher income area where the residents can still afford to get takeout.
Okay, So it's going to be based on income characteristics. Murad?
I was gonna say restaurants that own the land instead of paying rent.
I think Murad, we're going to end on Murad because that was the brilliant one. So pat yourselves in the back, Murad. I think that is one of the real keys. Do you pay rent to a landlord, or do you own the building outright, or rent it to yourself? Because there's a pizza place close to West Campus. It's on the other side of the tracks from Questrom. Small one-story, it's a two-story building, yellow, it's been there forever.
The Anthony's.
Help me out, what's the name of the pizza place? T. Anthony's, thank you. Exactly, T. Anthony's. BU today did a spotlight on T. Anthony's, and the guy at the very end of the interview said, the only reason I'm surviving is because I own this building. I can pay myself less rent because we're just not doing the business. There's just fewer BU students, there's fewer people coming by. And because I own the building, survive the pandemic. I might not survive well, but I'm going to survive. If I had to pay rent like some of the people next door to me, no way we'd stay in business any longer. So great idea, Moran. Thank you very much. All right, let's jump back. So what we want to do is we want to do something which is a linear probability model. And we want to convert whether an event happens or not into a binary variable, 1 or 0. 1 means yes, the event happened. It's a dummy variable. And 0 means no, the event did not happen. And we'll just run a regression. The difference is on the left side, it's now a dummy variable, where up till this moment, all our dummy variables have been on the X or right-hand side of the regression. And when we look at the regressions, the coefficients are going to be interpreted differently. Instead, the new way, when you have a dummy variable on the left, the coefficient is the percent. It's going to show the percent that's going to be changing, okay? Positive coefficient means the probability of the right-hand side variable is going to yes happens. Negative coefficients means the probability, the chance that something on the X side happens goes down. Positive coefficients are not always good. Negative coefficients are not always bad. Let's say this twice, okay, all out loud. Positive coefficients are not always good. Negative coefficients aren't always bad. Come on, join with me. Positive coefficients are not always good. Negative coefficients aren't always bad. Let me give you an example. I'm running a linear probability model on who flunks QM222. Positive coefficients means you are more likely to flunk. That is not good, okay? Negative coefficients are good in that case. So the key point of this slide, if you're going to scribble some notes on it, is it depends on the left or right side whether you want positive or negative coefficients, okay? If you're thinking about who buys a house, then positive coefficients are good. If you think about who flunks a course or who gets sick from COVID and dies, positive coefficients are bad. I don't know if that makes sense. Maybe? Is anyone out there listening? Filippo is. Thank you. Great. So in our book buyer example, we want people to buy books because as an academic, I believe reading is good, especially if you read my books, right? Make great holiday gifts, Amazon.com, just type Zagorsky under the author. You can give my books to your father, mother, whatever. I'm sure they'd love you. That was I'm smiling under my mask, okay? Yes, I write books. Yes, you can buy them on Amazon. No, I do not believe your parents want to read my books for Christmas or Hanukkah or Kwanzaa or whatever holiday you have, okay? Higher education, higher income, more likely to buy a book. Very useful for risk analysis. When you get to core, which is next spring, is this fall? Yeah, I'm sorry, COVID challenge on the dates and times, okay? You're going to do a whole bunch of risk analysis as part of, I think the course is 323. There's core and then there's like math for core. So math for core is all about risk analysis, whatever the number is. I think it's 323. It is, great. So risk analysis, how do you do it? One way, they'll teach you lots of ways, but one way is a linear probability model with 0, 1 on the left-hand side, where risk factors. Does the customer not pay the bill? Does the customer welch on the debt? That would be something really important to understand, right? True, false. Or, will the customer go bankrupt? That's a risk analysis, okay? So I'm going to send you off into a breakout room for a moment. I guess I'll just talk to Isabella since there's only 2 of us here, okay? Socially distant, stay 10 feet away, okay? And can you come up with, as a group, a risk function, something with 0 or 1 on the left side, and what would be your right-hand side variables? So it's not any probability model, it's a risk probability model, okay? So we're starting on 323. We're starting to get you thinking about risk. What would be risky that you want to worry about in a business that you're creating? And what would be some of the explanatory factors? And if you really want to go whole hog, are they positive or negative? So let me set up, are there any questions while I'm setting up the breakout rooms? All right, we'll see you in 3 or 4 minutes if there are no questions. And Rithvik, I have not been looking at chats or anything like that. Is there anything going by I'm supposed to know about?
No, you're good.
All right, just yell at me if you're not seeing the screen or any of these other things going by.
Yeah, no worries.
All right, so Isabella, I guess you're on the spot.
Yeah.
Please.
Maybe I was thinking about risky projects or investments for other, like I'm thinking about hedge funds in particular.
All right.
If you want to pursue some sort of deal or project, and then you have to analyze the ROI or if they.
Well, okay, hang on. But this is linear probability, so it's 0, 1. So ROI is does that make sense? So ROI is, return on investment, 7%, 12%, 18, a whole bunch of different numbers. It's not yes, no for risk.
But is project sort of like a deal? Is that in the right direction or no?
All right, so I'll give you your own answer. You're concerned about ROI and you have a cutoff. As a hedge fund, you only want to do deals greater than 10%. So if you only want to do deals greater than 10% ROI, I'm making up 10%. Any number you want. Will this clear the barrier, clear the hurdle? Yes or no?
Oh, okay.
So will it be greater than 10%? 1, not greater than 10%, 0.
Right. And the positive aspect would be 1.
That's
so positive hurdle area.
Yep. So that would be an example of taking and creating a risk function. Because in general, when you're looking at lots of deals, and when you start off, you're not going to look at lots of deals. They'll give you a deal to work on for 6 or 8 months. But then as you get higher and higher in the organization, you're sitting there and 10 deals come in. And you have 2 hours in the morning to look at 10 different deals. And basically in your head and everybody else's head around the table is, do we do the deal or not? Yes or no? And we only want to do the deal if we're going to expect to make money. And it'll be pretty clear if you're sitting around and people are making pitches. So what happens for a hedge fund is you'll go off and there'll be 3 or 4 other people on your team, maybe 2, it doesn't really matter. A couple of people on your team, they'll never assign you on your own. And you'll come in and there'll be a bunch of people sitting around a conference room table and you'll make your pitch for 15 or 20 minutes and they'll grill you. The whole idea, you're like, well, I think, I was told we should investigate this company and my suggestion is we really do. And you'll make your pitch and then 10 other people will come in and make their pitch. And then people will sit there and argue back and forth and go, which deal should we do? And 1 or 2 are probably going to be obvious. Of course we should do this deal. And 1 or 2 are probably going to be like, no, it doesn't fit. We don't like it, there's too much risk, blah, blah. And then the ones in the middle, that's when the analysis comes in. And that's where sometimes doing these kind of functions. And if you've done a lot of deals, you don't do a regression because you've done the regression in your head and you sort of know all the factors. Yeah. It's a bit like, I don't know if you've ever been to a pitch day.
Yeah, I've been the very minute ones.
So it's where Radio Shack used to be on Comm. It's the Build Lab, I think it's called.
Yeah.
So like once a semester they have a pitch day. I highly encourage you just to watch a pitch day. And your whole goal, if you're going to go into hedge fund kind of things, your whole goal is to just watch the pitch day and say, if I was to invest some amount of money, I don't know, something small, $5,000 or $10,000, and I had the ability to invest in 2 companies, I don't know, or 1 company, which one would I, definitely, and which one would I run screaming from? And it's useful to go to pitch days.
Do you have one this semester, or is it virtual?
I don't know, Rithvik, did you see, I think I saw a virtual pitch day go by. Rithvik, did you see a pitch day for the Build Lab go by?
I have not seen a pitch day.
No. I encourage you also to watch a pitch day.
I definitely will.
I think both of you will go off and, do well in business. So I'm expecting great things out of both of you.
Thank you.
So just understanding pitch days are kind of important for the modern business world. When I was growing up, when I was your age, I was like, there was never a pitch day. They did not exist.
Right.
And now it's like pitch days all the time. Please remember, I know I'm on tape, if you do go to pitch days, some of the pitch days have a fair amount of wine, canopies, things like that. Never drink at a pitch day. Never. I mean, drink water. It can be very expensive. I've seen people do dumb things at pitch days. I want to get in on round 1, where a week later they're like, why did I invest in this? Because trying to get out of a startup is very messy. Having experienced it in my own life. Getting out of a startup that is failing is just horrendous. It just takes a lot of time and energy compared to how much money you've invested. All right, so everybody seems to be back. And do we have any ideas from, we'll do room 1, Dakang, Shani, Jason, Junchen, Kenzie, Sungwoo. Anybody?
Yeah, we talked about I guess stocks, I guess blue chip stocks are very safe versus penny stocks are more risky.
Okay, so safe stocks versus non-safe stocks, and any ideas on the right-hand side? What factors we'd investigate to determine that? Any X variables? I guess there wasn't. So we'll go on to room 2. Ashley, Christopher, Filippo, Gunsha, Joel, and Denise.
So one idea we had is about the hospital business and how healthy is the population, like where you want to start the hospital business. And the variables would be what age people are, what their income is, and yeah, I can think of only 2 for now.
Okay, so age is an important one for health. Especially for deciding where to put a hospital. Income is another one, whether they can pay their bills. I would say also insurance is important because there are some areas, at least here in the United States, where the income is low, but a lot of people have insurance. And for example, the government pays, for example. So I'm perfectly happy to put a hospital there because I know I'm going to get paid. I'm not going to get paid by individuals, but I get paid by the government. All right, room 3, Annika, Carvey, Michaela, and hang on, let me scroll down to see who else is in room 3. Maran and Rithvik is not there. Okay.
Yeah, so we spoke about starting a gym, and we talked about how factors would be the average age of the people, also the cost of land in that area, etc.
So whether a gym survives or not survives. Excellent idea. How about room 4? Kira, Matt, Nicole, Priyanshi, and Serenity.
We talked about completing an acquisition, determining how risky it was, and the variables you could look at is how malleable the new company is, if you have enough leadership, if you have enough funds.
Okay, that's a pretty interesting idea, whether an acquisition is going to be successful or not. For those of you who ever do mergers and acquisitions, almost the vast majority of mergers and acquisitions are considered failed mergers and acquisitions. Very few are successful. Lots of people go in with really high hopes, and it's just like dating. You go in with high hopes, and then nope, doesn't work out. Nope, doesn't work out. But sooner or later, hopefully it does work out. Room 5, Iris, Isabel, Kate, Max, and Duren.
We talked about if you're going to be lending money to someone, marital status, and then also proximity to record store. If you're starting a record store business, if you're close to a concert venue.
Wow, record store business. I haven't heard that one in a while, but thank you, Kate. That was an excellent idea. It gives me something to think about. Let me tell you that when CDs came out, I told my wife we had this massive record collection. She had a massive record collection. I had like 5 albums. I said, no one's ever going to listen to records again. Let's dump them. We sold them all off, and then suddenly records became a big thing again. And my wife, she was steamed at me. So you never know when these things will come back. All right, room 6. Abdullah, Caitlin, Ilana, Raphael, and Sam.
We kind of talked about like a bank investing money in like a business. So some things like the uniqueness of their idea, like the strength of management, the amount of money they're asking for are all considerations.
So really important, there actually are these regression models at almost all banks. Do we make the loan? Do we not make the loan? And there are actually separate models for people for mortgages, for car loans, for business loans, just like Sam was saying. There's a whole bunch of factors. Because in the old days, what happened was that people walked in and they chatted face to face with a banker, and the banker would say, yes, we'll give you a loan. No, we won't. And today it's much more automated so that you can use, I don't know if you've ever seen the ads on TV for Rocket Mortgage. You pull out the app, you fill in a bunch of things, and Rocket Mortgage asks this probability algorithm and says, do we give the loan or not? If the Rocket Mortgage algorithm comes back with a like 95% chance they'll pay off the loan, you get the loan. If it comes back with a 10% chance you paying off the loan, they say, sorry, you're denied. Relatively straightforward. Sam, you've got a long history in banking. I see ahead of you. Nice job. Room 7, last but not least, Stephen, Ayush, Hannah, Jacob, and Kevin.
Yeah, so we looked at it from like B's perspective, and we were gonna measure like how likely a student is to come back on campus.
Great.
Yeah, and we use factors such as like income level and like number of cases in Boston, and also like how far you are from Boston.
Yeah. And let me say that I actually run these same kind of probability models in my head all the time. You know, who's going to show up on campus? Am I going to get sick from them on campus? All these kind of things. And so I'm sure as the provost and the president, you know, they are all thinking about these exact same probability models. Great ideas. All right, let's jump back to the slideshow, because I know you're all going to be upset at me if I don't actually get to a regression that we're actually going to run with Excel. All right, it wouldn't be QM222 if I didn't open up Excel. There's a quick note. Sometimes linear models break down. Why do linear probability models break down? Because look at this point up here. If we go just a little bit more, we can be above 100%. And there's a chance that sometimes we can be in a negative range with linear probability models. Because with linear probability models, you can go above 100 and below 0. But in life, 100% is the maximum. I know your gym coach screened it to you and said, give me 110%, but in reality, 100% is the max. And that's why they're teaching gym and they're not teaching QM222, okay? Because they believe you can do things like more than 100%. In more advanced packages, some of you are going to go off and use these kind of models, so please remember this. There are more advanced packages that do things like logistic regressions. And logistic regressions say the form is not a line, instead it's more like an S. And the S maxes out at 100% and mins out at 0. So you can never go below 0%, you can never go above 100%, and you don't look silly going, our chance of doing a successful deal is 200%. So you can do it, you need packages like R or Stata, you cannot do it in Excel, all right? Sorry. Anyways, just keep in mind, if you're doing these things, you might need a more advanced statistical package. Okay, so interpreting the linear probability model. we're going to put y on the left side, and that's going to be 0 or 1. But in the linear probability model, we're always testing on y that y is 1. That true is going to happen. Once again, true might not be good. True might be you flunk, you get sick, you die, all these kind of things. You don't get paid. But y is always, we're always trying to predict if y will happen. Okay? And then what we're doing is we're looking at the probability when we change some x variable holding all the other factors constant. And all the other factors we're calling z in this particular model. All right, if you're going to mark star, this is the second slide that you mark star. This is the second most important slide in the slideshow. And what happens is we're not looking at the probability of change. We're looking at the total number. So we don't say things like the probability went down by 10%. Instead, what we say is we say the probability went down by 10 percentage points. For those of you who have ever looked or heard about somebody working in finance, they talk about basis points. Why the heck do finance people use the word basis points just to confuse mere mortals? No, because that way there's a distinction between percent, it went down by 10%, or so in finance, if something went down by 10 percentage points, they said it went down by 1,000 basis points. And that way you don't have, you actually hear a big difference between percent and percentage change. Does that make sense? Let me say that again. Something can go down by 10%. Let's say I have income of $100,000 and my income goes down, let's make it different, $50,000. My income goes down by 10%. If I have a $50,000 income and goes down by 10%, my income goes down by $5,000. But what if my income goes down by 10 percentage points? Means something slightly different. All right, let's work and talk about a couple more examples. So here we have an online bookseller, and we have purchase as 0 or 1. Okay, we have some constant. What does this constant say in simple words? It says that there is a 46% chance somebody goes and buys a book on this online book. And then there's two different X variables, price and whether the website has a simple design or not. So let's look at simple design only because I've just highlighted it. What we're doing is we're doing A/B testing like we did in the experiments. And when we do the A/B testing, we have different prices and we have two different websites, simple and complex. If we give them a simple website, what happens? Is a 1 percentage point increase when we give them a simple website versus the complex website. So that boosts the chance they buy from 46% to 47%. If it was a 1% change, then instead of boosting it by 1 percentage points, it would take 46%, multiply that by 0.01, and it would go up by 0.5%. So there's a difference between a 1 percentage point change, which is boosting it by 1, and a 1 percentage point increase, which boosts it by 0.5. That is probably the most confusing statement I'm going to say all day today, so let me say it again a little slower. Okay? When we have the simple design, it boosts the chance of you or somebody making a purchase from 46% to 47%. That is a 1% increase, 1 percentage point increase. If I went up by 1% from 46%, 1% of 46 is 0.045, which is half of 1%, 1 percentage point. So it's sort of important to understand the difference between percentage point increase and a percent change. Sam, you're still looking confused. No? Anybody else confused? All right. So anybody have any idea what this coefficient says on price? What does that number with a minus sign tell us? Filippo, go for it.
There's a negative relationship between your probability of purchasing and the price, like it's inverse.
Perfect. That's high level. Can you be low level? Tell me exactly.
Oh, like the probability of you purchasing goes down if it's not free by 4%.
4 percentage points.
By 4 percentage points, yeah, to like 41%.
So let me just change it just slightly. If price goes up by $1, so we increase price. I don't know what the price was, but let's say the price was $4 and we bump it to 5. So price goes up by 1 unit, $1. The probability you purchase goes down by 4.4 percentage points. So if you had a 46% chance before, you now have a 41.5% chance of buying the book. Raise price by $1, lower the percentage by 4.4 percentage points, not 4.4%. Does that make sense? If we lowered it by 4.4 percentage points, let's call it 5%. We lowered it by 5%, 5 times 46% is about 2.25 percentage points. And that's different. It's only half the amount. So it's important whether we're doing percent change or percentage points. Hopefully that was not too confusing. All right, and for those of you taking notes, there is what I just said. So, linear probability models, positive, relatively simple to understand and estimate. Downside, probabilities can be outside of 0 and 1. So, for example, what happens if we boost the price by $10? Anybody besides Filippo? Boost the price by $10. Iris stuck her hand up first. Go for it.
Would you like lose the purchase probability by 40%?
Okay, so
would it be like
10 times 10 times 0.043 is, usually I'm not trying to be precise, but this is the one time I really like being precise. 10 times that number is what, Iris?
43.5.
43.5. So when we subtract that from our baseline of 46, we're almost down to 0. If we raise the price by $20, how much do we go down, Iris? And feel free to say, I don't know. What are you talking
87%.
87%. So it drops it by 87%, but the most we could have with the baseline with the intercept is 46 plus 1 for a simple design. The most we could have is a 47% chance. 47 minus 87 is impossible. You can't have a negative 40 some odd percent chance, a negative 40% chance of them buying something. Thank you very much. Rithvik, please give her full credit for today. So sometimes in cases you can end up with predicted probabilities greater than 1 or less than 0, which just do not work. So we have 11 minutes left. And what we're going to do is we're going to do Wall Street Journal 2. And we have a bunch of different columns. And here's your goal. Your goal is to come up with a regression that looks very similar to this, and then interpret what the regression coefficients mean. So I'm going to open up the file. Alana, you're very close to me. Can you see this online?
Yes.
So this is fake data, all right? These are not real data from the Wall Street Journal. So many times we use real data in this class. This is a fake file. So there are 84 people in this file, and they have some zeros and ones. 0 means they do not subscribe to the Wall Street Journal. The Wall Street Journal, for those of you who've never seen it, is sort of the leading business newspaper, the daily newspaper in the United States. There's also Asian editions and European editions, but there are others. For example, in Asia, the Financial Times is more widely read than the Wall Street Journal. In Asia, it depends which part of Asia, but there are many other Asian newspapers that are also read. Anyways, Wall Street Journal, 1, like here in row 9, this person buys the Wall Street Journal or subscribes. The next one down is, so the data are mainly sorted. So there's like a 1 person here at line 71, they subscribe also. Income in $10,000. So in cell C4, this person's income is $66,000. The next person's income down here, this person's income is $50,000. This person's income is $42,000. Investable assets. So this is the amount of cash they have to buy stocks, bonds, put in the bank, things like that. This person has $26,000 to invest. This person doesn't have very much at all. This person has $25,000 to invest. All right, so everything's in 10,000. So your job is to run a linear model. Wall Street Journal subscriber 01 is the left side variable, and the right side variables are going to be income and investment amounts. That's probably going to be pretty easy for most of you. I think we've done regressions like for 3 months now. But the harder part is, can you, in simple words, explain the coefficients? So type it in next to your Excel, and then we're going to make a prediction. We're going to see how much somebody with 50,000 in income and 25,000 in investable assets. What's the chance they subscribe to the Wall Street Journal? All right, so I'll give you a couple of minute head start, and then I'll interrupt when I feel that I don't have enough time to complete everything before the class ends at 11 o'clock. Okay, so we're going to do regression. We'll pick OK. The Y range is the dummy variable. You subscribe or don't subscribe to the Wall Street Journal. The X range is going to be 2 columns, C and D. and they contain income and investable assets. We want to make some labels. We do not want to pick constant and zero. If we pick constant and zero, we're saying is somebody with no income and no assets does not subscribe to the Wall Street Journal. Let me tell you personally, when I was a grad student, I had no income, I had no investable assets, but I subscribed to the Wall Street Journal. I read it every day. So we'll pick OK. And now we have a bunch of coefficients. So we'll format these coefficients. We'll make our prediction, and then we'll explain what they mean in simple words. So we're going to insert a column, put in some values. See if I can spell values right. Values, the intercept is what? I have no idea why these numbers showed up. The intercept is 1. Income is 50,000, so we're going to type 50 because we're dropping zeros. Investable amount is 25. Probability. Someone invests, someone subscribes, subscribes is equal to some product of A17 through A19, comma, C17 through C19.
Professor?
Yeah, how did I mess up, Gunsha?
Sorry?
How did I mess up? Go ahead.
Oh, I just had a question about how we put the values 1, 50, and 25. Are we supposed to put them in 10,000s as well, or doesn't it?
So 50,000 is 5. This is 2.5. Thank you, Gunsha. Please pat yourself on the back. So that I was looking at the numbers going, this is just nuts. And there it is, 18%. All right, so what I did by typing in 50 and 25 is I gave people $500,000 worth of income and $250,000 of investable assets. And that means they're definitely a Wall Street Journal subscriber. Anyway, so sorry about that. Sometimes I go a little too fast. Anyway, so the probability they are a subscriber is 18%. However, you know, once again, if we had a couple extra minutes, I only have 90 seconds left. You would know that there's some range that this falls into. It's not exactly 18%, but it's around 18%. Okay, so what does this say in simple terms? Let's talk about this minus 0.04 number. What does that say? Every time income goes up by $10,000, there is a 4% less chance, 4 percentage point less chance. So if I boost this person's income from $50,000 to $60,000, what's going to happen to my predicted value? It's going to go from 18 down to, somebody help me out, somebody who has not talked. Kevin, go for it.
I talked already, but 14%.
All right, so if I go from 50,000 to 60,000, it's going to go from 18 down to 14%. And if I lower the income down to 40,000, it's going to jump up to 22%. Thank you, Kevin. 22%. Excellent. So more income is bad for being a Wall Street Journal subscriber. Okay, investable amounts. What happens if we boost this from $25,000 to $35,000? We give them an extra $10,000 of income. Let's try it again. $10,000 of investable assets. What happens? Increases. Let's try it. 3.5, we're going to see this jump from 22%, hopefully to 48%. Woo! I love math. It works out. Okay? So the idea is for Wall Street Journal subscribers, income is bad, investments are good. And in some ways that makes sense. Why? Like doctors who earn a lot of income, they don't have time. They just let somebody else invest their money for them. People with low income but high investable assets, they're like, oh, I can do it on my own. Right? So let's look at university professors. Low income, low investable assets. Woo! No, we don't read the New York, the Wall Street Journal, okay? Can't afford it. All right. That was also, I'm smiling here behind my mask, okay? Anyways, it's 11:01. Hopefully all of you have a happy and healthy, safe weekend. I look forward to seeing you when? Monday, exactly. And we'll do more linear probability models on Monday. Stay healthy. Bye-bye.
Thank you.
Thank you, Professor.
Thanks.
Steven, go for it.
Hi, Professor.